To understand how different computers and systems can communicate over the internet, network engineering uses reference models. They divide the incredibly complex process of sending and receiving data into smaller, logical, and standardized parts called layers. The two most important models are OSI, used for theoretical study and standardization, and TCP/IP, the practical architecture that actually makes the internet work today. The OSI, Open Systems Interconnection, model created by the ISO, International Organization for Standardization. This model divides network communication into 7 layers. Think of it as an assembly line. When you send a message, the data goes down from layer 7 to layer 1. When the other computer receives it, the data goes up from layer 1 to layer 7. 1. Physics deals with the actual hardware, transforms data into electrical signals in copper cables, light in fiber optics or radio waves in Wi-Fi, and transmits the bits, zeros and ones. 2. Data link organizes bits into frames and uses physical addresses, MAC addresses, to move data between devices on the same local network, such as on a switch. 3. Network. This is where routing happens. It uses logical addresses, IP addresses, to find the best path to send packets from one network to a completely different one. 4. Transport ensures that the data arrives correctly by dividing it into segments. It controls the flow and checks for errors using protocols such as TCP or UDP. 5. Session opens, maintains, and ends communication, the session, between two devices, ensuring that there are no interruptions while the data exchange takes place. 6. Presentation acts as the network translator, handles data formatting, compression, and encryption. For example, transforming data into a JPEG image format or applying SSL/TLS for security. 7. Application, the layer closest to the user. This is where network software operates, web browsers, email clients, using protocols such as HTTP, HTTPS, FTP, and DNS. The TCP/IP model. While OSI is the perfect theory, TCP/IP, Transmission Control Protocol, Internet Protocol, was created by the US Department of Defense to be practical and robust. It groups the functions of the OSI model into just 4 layers. Some modern literature divides it into 5, separating network access, but 4 is the historical standard. What is the difference in practice? The main difference is the approach. The OSI model was built with the layers defined before the protocols were created for them. It is a purely structural reference model. The TCP/IP model was built in reverse. The protocols already existed, and the internet was already being created. So the model was designed to describe these protocols that were already working in practice. Today we use OSI to diagnose problems, e.g., the problem is in layer 3 of the router, or it's a layer 1 error in the cable, and we use TCP/IP to build the network.